Okay, anyway, it's a teaser. How it all began, or once upon a time, we started having computers. And some of us, or many of us, started with computers quite early, a little bit earlier, a little bit later. But then what happened, of course, in the time we had, then we had only the possibility to process things actually one by one sequentially. And if you remember the computers from the 60s, you would have bit sequential processing in a 18-bit computer or something like that, because the amount of hardware you needed was actually too much to do anything else. I'll skip a little bit from here. Somewhere in the early late last millennium, early this millennium, we started then collecting computers together into clusters. We started collecting them into grids. And on the Ruđer Bošković Institute in the Center of Information and Computing Science, we actually started with that very, very early. But then we had always the same kind of problem. How do you actually program this kind of things? Well, yes, we all somehow, for some reason, succeed to force some strange languages like C not to actually forget about a pointer somewhere, or not, or to increment all things in a proper place and so on in huge amounts of code. And then suddenly we had another problem, and that is now suddenly we have parallel possibilities. So how do you actually parallelize our frame of mind of thinking in a very serial way about algorithms? And we all struggle with that. Then we have a lot of knowledge about how is each thing done. But we don't actually, for each new program in any of the languages we communicate with computers, they're not really languages. They're formal languages. They have nothing, they have almost nothing natural in them. No context. You were talking about context. The context in a language is an extremely important thing. In most of the programming languages, it doesn't matter which statement you say after a previous statement. If it will either work or won't work. There is no context around it. So, quite interestingly, 1978, Mr. John Backus, you all probably know about John Backus, you know about the Backus-Naur form. John Backus was, and is actually, I think he is still alive, famous not only in computing sciences, but very famous in linguistics, general linguistics. I studied general linguistics, and I work with computers parallelly. That's a kind of balance. Backus was the inventor of ALGOL and the Backus-Naur form is really, I mean, if you look at YAC or anything like that, it's all actually based on Backus' work. Well, what does he say? 1978, conventional programming languages are growing ever more enormous. Well, we see it with APIs, and all kinds of ideas we put in, and then we do something which we call a language, and we call it, I don't know, OpenGL, and there is no language in it. It's just enormous amount of words which actually describe an extremely complex API. There is no language in OpenGL. It's not a graphic language, it's a graphic set of calls. Inherent defects really are there, and here we see what there are. Programming into world of expression and world of statements. Inability to effectively use powerful combining forms for building new programs from existing ones. You have a lot of existing problems. How do you combine them together to make anything new, except by tearing it apart and taking those parts of those programs which you can then put again together, hopefully into a new framework. And, of course, there is a lack of useful mathematical properties. Actually, none of our languages knows how to, I don't know, make a magnitude out of a quaternion, or what is a multidimensional contradiction in multidimensional logic. So each time you do something, you actually have to browse through all the literature and make the algorithms for yourself. And somebody else did it twice, 10 times, 100 times. But you can't, there is no useful possibility to combine them together. So Backus said, each new language claims new and fashionable features. You are quite aware of that. But this is quite important. The few languages make programming sufficiently cheaper or more reliable to justify the cost of producing or learning them. Let's skip from 1978 to 2005. A guy Steele, he was, well, he is quite known as a computer scientist, says, what might a language look like in which parallelism is the default? It's not a very long time ago. Languages in which, at least conceptually, all of the elements are all the time involved. And he says that might change your mindset a little bit. What Guy Steele was talking about is very, very important, of high productivity computing. Not high speed computing, not high performance computing, high throughput computing, big data, visualizations, Internet of Things, all that things we now want from computers. We actually do like it, computers. Otherwise we wouldn't sit here. But what I do not like in computers is that absolutely enormous, mind-boggling amount of work necessary to make a reasonably simple algorithm to work. What I mean that mind-boggling amount of effort, that is, if I now want to write in C a little program to make a two-dimensional index array of I don't know, complex numbers, I'm absolutely certain after many, many years that I will forget at least one semicolon somewhere. And that I will have to recompile it at least, it always happens to me. Always, at least 2-3 times until finally I get it compiled. Then only can I think if the algorithm is really working what it should do. So high productivity computing is a completely different thing. How do we now make something, a language, an approach, a human interaction approach, which would actually solve most of those problems? Something understandable both by computers and by humans, but understandable by humans. The problems here are always the same in a way. Intercommunication, synchronization, all that kind of things, which we always have to rethink for each particular application. Okay, we use MPI or PVM or whatever, but then just sending data over MPI is not a simple thing, writing down, yes, please give it to that computer. But it's a set of calls where you have to learn or find those definitions which say something like which you put here in something which is called blah, 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 blah. And then if you forget something of that, you get confused or the computers get confused. Anyway, so the initial idea about 10 years ago was to develop a system which would enable actually us to control in a reasonable human way the whole system, to say to the computer something which could then be automatically distributed as much